So let's talk a little bit about the fundamental identities. So you have seen these identities hopefully before. So we talked a little bit about the reciprocal identity. So sine is just 1 over cosecant. Cosecant is 1 over sine. Same thing can be said about cosine and secant, and tangent and cotangent. So we also have the quotient identity. So remember, tangent can be defined as sine over cosine. That's why we have the y over the x. Remember that the y was a sine, the x was a cosine. And then we have the cotangent, which is the cosine of the sine. All right. Pythagorean identities, please make sure that you know them. This you definitely need to know. So knowing that sine squared theta plus cosine squared theta equals 1. And you can always rearrange them to solve for sine squared and cosine squared. They're equal to 1 minus cosine squared and 1 minus sine squared. So this is going to be really useful when we start solving trig equations. Also knowing that 1 plus tangent squared equals secant squared, and also all the different alternatives. Same thing with 1 plus cotangent squared equals cosecant squared, and all the other rearrangements. All right. We have here the cofunction identities. This is going to be more for graphing, but they exist. If I move pi over 2 units and I do a reflection across the y-axis, you end up getting the other function as well. So this is just, this one here is more of an FYI. We will talk a little bit about it when we graph, but I mainly want you to know these guys. So reciprocal for sure, quotient, and Pythagorean. So if you feel like you don't know them, please do now, okay? So we're going to use these formulas. So I'm going to show you 2 different ways to do this. One of them is more algebraic. The other one's more geometric. So let's say, suppose that we got sine theta equals negative 4 over 7. And the terminal side of theta is quadrant 3. Find the rest of the trigonometric functions. Now, before we start off with this problem, there's something that I do want to show you guys. And that's that whenever we think about the quadrants, quadrant 1, quadrant 2, quadrant 3, and quadrant 4, there's a way to kind of notice or note when all of these guys are going to be positive and negative. So for example, in quadrant 1, all trig functions are positive. So all are positive. In the second quadrant, only the sine is positive. And since the sine is positive, therefore the cosecant should also be positive. In the third quadrant, tangent is positive. And because tangent is a reciprocal of cotangent, that means that cotangent also is positive. And in quadrant 4, cosine is the one that's positive. And as a consequence, secant will also be positive. So there's a really good acronym that we can that we can memorize. This is ASTC, which basically means all students take calculus. So that's another way that you can say this: all students take calculus. And you can see ASTC. Okay, so that's what that kind of just means, ASTC. So it goes in the counterclockwise direction. That kind of tells you where exactly things are positive and negative. Okay, so let's go ahead and show you how to do this example. So I'm going to do it 2 different ways. So we got this. We want to find the rest of the trigonometric functions. The first way that I'm going to do is using the Pythagorean identities. All right. So we know here theta is in quadrant 3. Okay. So let's take note of that. So we know that theta here is in quadrant 3. And if you see in quadrant 3, only the tangent and cotangent are positive. So only tangent and cotangent will be positive. Okay, so that's what we know. So the way that I'm going to find the rest of the trig functions is basically using the identities. This is going to be one way to do it. So the first way to do it is more algebraic, is using identities. In a second, I'll show you another way to do it. That's not how you spell identities. Identities. All right. So let's go ahead and figure out, we know what sine is. We know sine theta equals negative 4 over 7. So let's try to figure out cosine. So what I'm going to use is use a Pythagorean identity. And in particular, what I'm going to do, since I'm solving for cosine, I'm going to move the sine over and use this guy. So I know that cosine squared theta equals 1 minus sine squared theta. So to find cosine squared, I just got to plug in this negative 4 over 7 in here. 1 minus negative 4 over 7 squared. So I'm going to put that in there. So we're going to have 1 minus negative 4 over 7 squared. And that's going to give me 33 over 49. Remember, this is cosine squared. And now all we got to do is take the square root to both sides. Add plus or minus. So we get that cosine of theta is equal to plus or minus square root of 33 over 7. Now remember, tangent and cotangent will be the only ones that are positive in quadrant 3. That means that cosine has to be a negative. Oops. So the cosine should be a negative. Alright, cool. Alright, now how can I figure out what tangent is? Well, in order for me to figure out what tangent is, tangent of theta, because now I have the sine and the cosine, I know that tangent of theta is sine over cosine. So the sine in this case was equal to negative 4 over 7. The cosine was equal to negative square root of 33 over 7. So this is just going to give me negative 4 over 7 divided by negative square root of 33 over 7, which gives me negative 4 over 7 times 7 over square root of 33, negative. 7's go away, so I'm left with 4 over square root of 33. And you can rationalize this as well. Now that we have sine, cosine, and tangent, I can easily find cosecant, secant, and cotangent. Because remember that cosecant is just going to be the reciprocal of sine. So all I'm doing is just flipping this guy. So this will be negative 7 over 4. Secant is just flipping the cosine. That's going to be negative 7 over square root of 33. And then cotangent is just going to be flipping the tangent, which is positive square root of 33 over 4. So now we have all 6 of them. All right. So this one was more algebraic. All right. Now there's another way. So this was the first way, using identities. A second way to do this is using geometry. Now, one of the things that you have to do is first locate theta. Okay, so theta here is in quadrant 3. So the way that we're going to do it is that we're going to draw an angle in quadrant 3, and we're going to write a theta value that is attaching to the angle and the x-axis. So this should always be attaching in the x-axis. And what we're going to do is we're going to have an upside down triangle this way. All right. So we know this is theta. Okay. And notice that in this side we got sine of theta equals negative 4 over 7. Now remember that the sine of theta, if you think of right triangle trigonometry, is the opposite over the hypotenuse. So you can see that this guy's going to be the negative 4 over 7. So how do we find this third side? Well, we can just use the Pythagorean theorem. So we can just use a squared plus b squared, which is going to be negative 4 squared, equals 7 squared. But a squared plus 16 equals 49. Subtract the 16 over, you're going to get 33. So a equals plus or minus square root of 33. And notice, because I'm in quadrant 3, it would make sense for this side to be the negative part, because it's a negative x. So we should be negative 33, not the positive. And now, because I know what sine is, negative 4 over 7, we can easily figure out what cosecant is. which is just negative 7 over 4. And now we can just figure out the rest of it. So we know that in this case, the cosine is going to be, you can either use SOHCAHTOA or you can just use the fact that the cosine is the x over the r. Well, x is just going to be the negative square root of 33 over 7. So therefore the secant is going to be the opposite of it, which is going to be 7 over negative square root of 33. The tangent of theta is the y over the x. Notice that the y is going to be negative 4 over negative square root of 33, which is 4 over square root of 33. And then therefore the cotangent will be the opposite of that, which will be square root of 33 over 4. And notice that you get exactly the same thing here. Okay, so you have an option. You can either use identities or you can either use geometry. Okay, so whichever you'd like to do. If you're more of a fan of algebraic stuff and using identities, you can do that. If you're more a fan of a geometry, then do that. Now, the one thing that I will tell you about geometry is that if you're going to do this triangle, make sure that you draw the triangles correctly. So a triangle in quadrant 1 will look like this with the theta value. A triangle in quadrant 2 will look like this in the second quadrant. A triangle in quadrant 3, like the one that we did, will look like this. And a triangle in quadrant 4 will look like this. So think about a little bow tie. So remember, look at the thetas, they're always hugging the x-axis. They're towards the origin in this direction. So they're always hugging the x-axis. Alright. Alright, so let's go ahead and do this example. Alright, so now we want, if cotangent alpha equals negative 4 over 3, where alpha is between pi over 2 and pi, find cosecant of alpha and cosine of alpha. Alright, so this time let me go ahead and just use geometry. I'm only going to use one method, but you can do it using algebra as well. I'm going to use geometry using that reference angles, that's what we call them. So let's first locate where alpha should be. So if I draw a coordinate, notice that pi over 2 is here and pi is over here. So my triangle, so I'm in quadrant 2, which means that my triangle should look something like this. And here's alpha. Now cotangent is the x over the y. Okay, so in this case, the x value is going to be the 4, and the y value is going to be the 3. Okay, so that's cotangent, the 4x over the y. So here's our x value, here's my y value. Now, which one should be negative? Well, in the second quadrant, then the x value is a negative sign, so this should be negative. Now, let's figure out what the r value should be. What should be the r value? So that's going to be the Pythagorean theorem again. So a squared plus b squared equals c squared. So a squared is negative 4 squared, b is 3 squared, c is just c squared. You're going to get 16 plus 9 equals c squared. C squared equals 25, so c equals 5. Now always this radius, this c value, the hypotenuse should always be positive. So I'm going to write here, hypotenuse should always be positive. Don't forget that. Alright. And now I'm going to just use geometry to figure out what cosecant alpha is and what cosine of alpha is. So remember that the cosecant alpha, which is the opposite of sine, is going to be the r over the y. Okay, and if you want to know where I'm getting this, you can just go back up to the notes and see that where we defined all of them. And you can see that the cosecant is just the r over the y. So r in this case is going to be the 5, which is the hypotenuse, and y in this case is 3. So it's going to be 5/3. And now let's look at cosine of alpha. That's going to be the x over the r. The x value in this case is -4, and r is going to be 5. Okay. And that's just it for these types of problems.